Welcome back. This is the second lesson recording for IM2, March 4th, 2021. So we're tackling the decimals activity where we are card sorting the numbers into rational, irrational numbers, natural numbers, whole numbers, and integers, and so on. So let's deal with those. Let's bring the integers up here. Which are the integers? Let's bring the titles to the top. We have rational numbers, irrational numbers, whole numbers, and natural numbers. Okay, natural numbers are all positive numbers. So, and integers include positive and negative. 0 goes into whole numbers. Okay, pi is a number that cannot be represented as a fraction. And it's a decimal that goes on forever, so it is an irrational number, as is a square root. If a fraction can be represented, a fraction is a rational number. Actually, 36/2 is a whole number, right? So it can be represented. It's more, to be more exact, it is a natural number. Negative square root of 10, it's an irrational number, and so on. I am going to let you do the rest. Okay, so card number 2. NG claims integers are always negative numbers. Is NG correct? If yes, explain why. If no, provide a counterexample. Well, integers can be negative, but integers can also be positive, like 0. Integers include all the natural number and whole numbers. Remember, integers are outside of the whole number and natural numbers, so I can use any of the counterexamples as 0 or 3 or 5 or 2 or 4 or any positive numbers are also integers. Tuya claims that square root of a whole number is always irrational number. Okay, square root of 4 is a whole number, but square root of 4 is 2, which is an integer, not an irrational number, and 2 can be represented as 2/1, which means that is a rational number. So I do not agree with 2. And Marcelo claims that the statement integers are always rational numbers. Are integers always rational numbers? Okay, so integers are whole numbers that can be negative. So +3, -3, and all of those. Can any number be represented as fraction? Yes, because -3, if I have -3, I can represent this in the fractional form of this is -3/1. I can change any whole number, any integers like 2 as 2/1 in fraction, or 175/1 in fraction. So all integers are rational numbers. Gianna claims that the statement decimal numbers are always rational numbers. Is Gianna correct? Well, there are some decimals that are not terminating. for example, I don't know, if you have 7.53217284, there are no repeating pattern to it. If it's not repeating, that means it goes on forever, or it's not terminating. That means it's not repeating and it's not stopping anywhere. It goes on forever. In this case, this will be irrational number. So I do not agree with Gianna. Now let's revisit squaring negative numbers. What is square root of -4? We're looking for two numbers that multiplies to itself to give -4. What number multiplied by itself gives -4? It's not possible, is it? Because -2 times -2 is 4, not -4, and also 2 times 2 is 4, not -4. So far we've said that there is no real number possible for that, but now we're going to extend that to complex number or imaginary number for now, and so we need a new way to represent this impossible. So here we go. The imaginary number is what we're introducing, and we're defining imaginary number, and that is represented by this italic I, and we're defining it as square root of -1. Or if I square both sides, then I squared becomes square root of -1, and square root and squaring cancels each other out, and so therefore you are left with -1. So I squared is equal to -1 is also another version of its definition. And I can be used to represent any negative square root number. So for example, square root of -25 can be represented as square root of -1 times 25, which is, I can separate them each as square root of -1 times square root of 25. And square root of -1, I have said, defined it as I, so that becomes I times 5, or 5i. What about square root of -7? Again, I can represent this as -1 multiplied by 7, which is square root of -1 multiplied by square root of 7, so that's going to be I root 7. So I would like you to try to do the decimals, number 6 to 11 now. Okay, so it's a card sort. You're sorting them into real number or imaginary number. Real number is anything, all the irrational numbers, rational numbers, they're all real numbers. Okay, they're all real numbers. The only time it becomes imaginary number is when you are dealing with square root of negative number. So that will be imaginary. This is real. Again, I have square root of -5 here, so that's going to be imaginary. This is real. Again, another square root of a negative number, and square root of a negative number. Negative square root of 10 is just a negative square root of 10. So this is real. This is real, and this is real, and this is again imaginary. Okay, representing square root of -9 by using I use the scratch paper. So square root of -9 can be rewritten as square root of -1 times 9. which is same as square root of -1 multiplied by 9, square root of 9. And I know that square root of -1 is I, and square root of 9 is 3. So I can rewrite this as 3i. What about square root of -13? Okay, again, I need to rewrite this as square root of -1 times square root of 13. And square root of -1 by definition is I, and square root of 13, I cannot simplify that anymore. So that's going to be square root of 13. Whether I write this as I root square root of 13 or square root of 13i, it does not matter. Actually, I take it back. They are both accepted, but my preference will be square root of 13i. I just think it makes a little bit more sense to have the real part and the imaginary part at the end. Square root of -50 is going to be same as square root of -1 multiplied by square root of 50. And I know the square root of 50 can be simplified as square root of 25 times square root of 2. Then I still have square root of -1 here. So square root of 25 is 5. Square root of 2 is just 2, cannot be simplified anymore. Square root of -1 is I. So it's going to be 5 root 2i. What about this? 2 square root of -12 just means 2 is being multiplied to square root of -12. Square root of -12 can be rewritten as square root of 4 times square root of 3, that's 12, and then this will make it -12. 4 times 3 times -1 is -12. So that becomes 2 times square root of 4 is 2, and we have square root of 3, and square root of -1 is I. So 2 times 2 is 4 root 3i. Okay, this is just a picture where you're looking for the bee. See if you can find the bee that is hiding somewhere in this picture. And finally, card number 12 says, you can just show me how you felt about today's lesson. Okay, so that's it for today, and you're going to add in table of content. We did number classification, and we introduced the idea of imaginary numbers. Thank you for listening.